So imagine you just rented like a massive cluster of multi-million-dollar AI GPUs. You are totally ready to train your model, but suddenly you realize those expensive chips are just sitting completely idle.
Oh, that is the worst. Just burning thousands of dollars a minute.
Right. And why? Because your data storage basically can't feed them information fast enough?
It's the ultimate bottleneck. I mean, people focus so much on compute power, they totally forget that storage is what actually dictates the success of those high-end workloads.
Absolutely. Well, welcome to the deep dive. Today, our mission is decoding the Google Cloud Platform storage universe for you.
Yeah, we're looking at a massive enterprise architectural guide today.
Exactly. And we are cutting through all that marketing speak to give you a real shortcut. We want to show you how to balance, FinOps, I/O performance, and data durability without getting totally overwhelmed.
Because treating all your data exactly the same is a surefire way to either hemorrhage money or just crash your applications.
Yeah, nobody wants that. So let's start with the baseline for modern cloud storage, which is cloud storage, or GCS.
Right, GCS. And that boasts an absurd 11 nines of durability.
Right, 99.99999999999%. I like to think of object storage like GCS as this massive valet parking lot.
Okay, I like that.
Yeah, you hand over your data, you get a claim ticket, and you don't really care where the valet parked it. It even has this intelligent auto-class feature.
Oh, right, where it automatically shuffles items to cheaper lots based on how rarely you actually ask for them.
Exactly. It saves you money without you doing anything.
That's a great way to look at it. But unfortunately, a lot of legacy applications, they just cannot talk to a valet.
What do you mean?
Well, they expect a strict library decimal system, where they know the exact aisle and shelf of their data, and that's why GCP has Filestore.
Ah, right. That's a managed NAS for your standard POSIX compliant NFS shares.
Exactly. So if you are doing like a lift and shift of an older enterprise app,
say a giant WordPress deployment or something.
Right. It's expecting that traditional file system structure. Filestore just lets you drop that old software right into the cloud. You don't have to rewrite or refactor a single line of code.
That's super convenient. But let's go back to that scenario I started with. A standard library system is fine for a basic app, but it is way too slow if you're running like a massive SAP HANA database.
But absolutely. For enterprise applications that need extreme speed, you bring in NetApp Volumes.
Okay.
It handles sub-millisecond latency, and it supports multiple protocols natively. It's incredibly fast.
Okay, wait. I'm going to push back here for a second because this is starting to sound like a total administrative nightmare.
How so?
Well, if NetApp is so fast, why do we need completely separate tools like Parallelstore and Managed Lustre? I mean, why not just use NetApp for everything and save ourselves the headache?
Because, well, fast means different things depending on the actual mechanics of the workload.
Okay, explain that.
Take Parallelstore. It is built specifically for AI and machine learning using DAOs. Yeah. DAOs essentially bypasses the traditional operating system kernel entirely. It talks almost directly to the storage hardware.
Oh, wow. So it totally removes the middleman.
Exactly. It delivers millions of IOPS as ephemeral scratch space. That is how you keep those expensive GPUs from sitting idle. They need tiny, rapid-fire bits of data instantly.
Ah, I see. Okay, so what about Managed Lustre then? Where does that fit in?
So Lustre solves a completely different speed problem, which is massive concurrent bandwidth.
Like what?
Think of supercomputing clusters doing genomic sequencing. You have thousands of compute nodes trying to read and write to the exact same file simultaneously.
Oh, wow. That sounds like a massive traffic jam.
It is. But Lustre coordinates that traffic seamlessly without bottlenecking.
Okay, that makes sense.
Yeah.
But here's the catch with all these ultra-fast options. They are completely useless if your data is stranded in some, on-prem legacy server across the country.
Right, you have to actually get the data there first.
Exactly. How do we bridge that gap without corrupting everything in transit? That's where the Storage Transfer Service, or STS, comes in.
Yes, STS is amazing. It completely automates the migration from on-prem or even AWS S3.
And it constantly runs checksums, right?
Yeah.
To verify every single bit is mathematically identical to the source.
Right, and it throttles the bandwidth so you don't accidentally take down your company's internet while migrating petabytes of data.
Very important.
Yeah.
And once it's actually in GCP, you have to protect it. The guide talks a lot about backup and DR, claiming it drastically slashes recovery time objectives.
It really does.
But how? I mean, is it just copying the data back over faster?
No, and that is the brilliant part. It actually enables instant virtual machine mounts directly from the backup storage itself.
Wait, really? So instead of taking like hours to copy a massive backup file back over to your primary drive?
The system just runs the VM directly off the snapshot.
Oh, wow.
Yeah, during a crisis, you mount the backup in seconds and keep the business running while you figure out what went wrong behind the scenes.
That is incredibly clever. So what does this all mean for you listening? I mean, the real insight here isn't just about saving money on different tiers.
No, definitely not.
It's realizing that storage is no longer just this passive bucket where you dump files. It is an active, intelligent network that fundamentally dictates whether your AI initiatives actually succeed.
It really is the silent engine of the entire cloud architecture.
Which actually leaves me with a final thought for you. With features like AutoClass automatically optimizing costs, and backup and DR letting us mount VMs instantly without manual restores, are we rapidly approaching an era where data storage essentially manages itself?
Yeah.
I mean, will the traditional storage administrator soon be completely obsolete?
Oh, that's a really interesting point.
Definitely something for you to mull over until next time.